वेलकम एवरीवन, वेलकम बैक टू माय यूट्यूब चैनल। आज की वीडियो में जो हम बात कर रहे हैं वो है मेम्ब्रेन एक्साइटेशन एंड कंडक्शन की। इन द रेस्टिंग unstimulated state, a nerve fiber is polarized so that the interior is negative to exterior. The potential difference across the plasma membrane, which is known as exolemma, is about -80 MV and is called the resting membrane potential. When it is excited by the electrical, mechanical, or chemical means, a rapid change in the membrane permeability to Na ions takes place, and Na ions diffuse through this and into the cell cytoplasm from the tissue fluid. This results in the membrane becoming progressively depolarized. The sudden influx of the Na plus ions followed by the altered polarized produce an action potential which is approximately 140 MV. Then we are talking about this potential is very brief, lasting about 5 meter per second. The increased membrane permeability for Na ions quickly ceases and membrane permeability for K ions increase. Therefore, K plus ions start to flow from the and return to localized area of the cell to resting state. A nerve impulse starts at the initial segment of the axon and is self-propagating wave of the electrical negativity that pass rapidly along the surface of the exolemma. Once generated, the AP spreads away from the site of initiation and is conducted along the neurites as the nerve impulse. The wave of the electrical negativity is initiated by an adequate stimulus being applied to the stimulus of neuron. Under normal circumstances, this occurs at the initial segment of axon, which is most sensible part of the neuron. The stimulus alters the permeability of the membrane of two Na ions to the point of stimulation. Now Na plus ions rapidly enter the axon. The positive ions outside the exolemma quickly decrease to zero. Therefore, the membrane potential is reduced to zero and is said to be depolarized. A typical resting potential is -80 MV with the outside of the membrane positive to inside. The AP is about 140 MV with the outside of the membrane negative to inside. In small diameter, the AP may not rise to as much as 40 MV. The negatively charged point on the outside of this now act as a stimulus to the adjacent positively charged exolemma. And in less than 1 meter second and polarity of the adjacent resting potential is reserved. The AP now has moved along the exolemma from the point originally stimulated to the adjacent point on membrane. In this manner, the AP travels along the full length of the nerve fiber to its end. As the AP moves along the nerve fiber, the entry of the Na ions into the axon ceases and the permeability of the exolemma to K plus ions increase. Now K plus ions rapidly diffuse outside the axon because the concentration is much higher within the axon. Then outside to the original resting potential is restored. Thank you so much guys. If you have any question regarding that, you can ask me. Thank you.